These are notes for Algebra 3, Unit 5, Analyzing and Transforming Functions. This is the section on inverse functions. Inverse functions, the purpose behind inverse functions is to learn about, if you know something about one function, then if it has an inverse, you can use the qualities of inverse functions to find something else about them. The purpose for Algebra 3 is just to introduce you to the concept of inverse functions, and then in later math classes we use them at a higher level. So inverse functions are functions that are inverses of each other, have special characteristics. The domain and range are switched. For example, x being the domain, y being the range, becomes y and x. And I'll show you that through these equations and graphs. The graphs are reflections over the line y equals x. And I'll show that to you as well. And the notation for the inverse of f of x is written f to the negative 1 of x. It doesn't mean you raise it to the negative first power. It's just showing that's an inverse. So the first thing I'm going to do is show you how to find the inverse given an equation. So we talked about domain and range being switched. So we're going to switch x and y. So this first example, I have y equals 3x minus 2. If I switch x and y, I get x equals 3y minus 2. Don't make it any harder, just switch x and y. But now I'm going to solve for y. So I have to add 2 to both sides. And I'm going to divide by 3. So I get y is equal to x plus 2 over 3, or 1/3 x plus 2/3. And then it would typically be written to show that it's an inverse of the function. So I'm going to say f to the negative 1 of x is equal to 1/3 x plus 2/3. My second example, I have g of x equals the square root of x plus 4. So I didn't talk about domain and range on this function, but I want to talk about it on this one. The domain on this is going to be x is greater than or equal to negative 4. And the range is going to be y is greater than or equal to 0. And I'll show you why I'm discussing this. And we've done a lot with square root functions. Like I've told you before, they really are my favorite function to work with because they're not symmetrical, they're special cases. So I like that. So I'm going to this is y equals the square root of x plus 4. I'm going to change to x equals the square root of y plus 4. To get rid of the square root, I'm going to raise both sides to the second power. So I'm going to square both sides. What that does is the left side gives me x squared. When you square root and square something, you're just left with y plus 4. So I'm going to subtract 4, I get x squared minus 4 equals y. So if I write the inverse, g to the negative 1 of x is equal to x squared minus 4. Now the problem I have here, and I don't want you to stress over it, I just want to point it out. The domain of this is all real numbers. But remember we said we're switching domain and range. So now I don't want this whole function, I only want the part where x is greater than or equal to 0. The range here was y greater than or equal to 0, so that becomes my domain. My domain here was y is greater than or equal to negative 4, so my range here becomes y is greater than or equal to negative 4. It may not make a difference to what you see now, but I need to show it to you in hopes that you understand this better later on. Not so much for this course, but for future courses. My next example, I have y equals x cubed plus 2, so I'm going to rewrite it as x equals y cubed plus 2. Subtract the 2, I get x minus 2 equals y cubed. To get rid of something cubed, I want to take the cube root of it. So I have to take the cube root of both sides. So I get the inverse is equal to the cube root of x minus 2. This f of x equals x plus 2 squared. So here I've got my domain is going to be all real numbers, and my range is going to be from from 0 to infinity. So at first changing x and y, so f of x is the same thing as y, so I'm going to make the x is equal to y plus 2, that quantity squared. Take the square root of both sides, and I get the square root of x equals y plus 2. Subtract 2, I get the square root of x minus 2 equals y. Then I'm going to write it as inverse notation. Now I know this function, the domain is going to be x greater than or equal to 0, which is fine, that's what the range is. But my range now is not going to be all real numbers. My range is going to be from -2 to infinity. So there's a problem with this one, and I'm going to address it on the back of these notes. We can look at these graphically as well. You don't have to have an equation for a graph. Let's just look at, let's just graph a line. So I'm not even going to give you the equation of the line, so it doesn't even matter. I've got a slope of 2. And I can go ahead, I'm going to get a ruler out just to make it nice and neat and even. And I can look at the points, and I don't need to get all the points. Let's pick the point -1, 5. So my function of -1 is a -5. Let's pick the point 1, -1. And how about 4, 5? Now to do my inverse, let's pick I'm going to switch x and y. So instead of -1, -5, I'm going to use -5, -1. Instead of 1, -1, I'm going to use -1, 1. Instead of 4, 5, I'm going to use the point 4, 5, 4. That's enough points. I can now graph this. This is what inverses look like. So the reason this is taught in this section is we've talked about transformations. We've talked about x-axis reflections. We've talked about y-axis reflections. There's also origin reflections. This one is a reflection over the line y equals x. If I were to draw the line y equals x, you're going to see a mirror image. So my original function is this one. If you take and just imagine you've taken this, flipped it over this line, y equals x, it's going to land down on here. So you don't need equations to find inverses. Let's talk about two more things. One is the horizontal line test. A horizontal line test is similar to the vertical line test. A vertical line test tells you if a relation is a function. The horizontal line test tells you if the function has an inverse. It's called one-to-one. So if I take a vertical line and I run it through here, this is the equation y equals x plus 2. Or horizontal line, I said vertical, horizontal. No matter where I put this horizontal line, it's only going to cross this function once. So this one has an inverse. Every line is going to have an inverse that's a function except for a horizontal line. If I run a line through here, It's going to cross it twice. So this one does not have an inverse that's a function. Let's go back a second. This one right here. If I were to draw this, x plus 2 squared, looks like this. If you drew a horizontal line through that, it's going to cross it in two places. That's why I knew it did not have a function. But if I looked at this and said, okay, let's get rid of this part. Let's not even look at that one. Let's just look at this. Well, then that part would have an inverse. And what that inverse would look like is like this. So that's why I said there's a problem here, because this one doesn't have an inverse, but there is the inverse of part of it. Horizontal line no matter where I put it here, this is going to cross it in multiple places. So no, this does not have an inverse function. We'll talk about that when we get to trig. Here's y equals 2 to the x power. We're going to talk about exponential functions. This one has an inverse function, so yes, has an inverse. All exponential functions are going to have inverse functions. This is 1 over x. No matter if I put the line down here, it only crosses it once. If I put the line up here, it only crosses it once, so this has an inverse. And my log base 2 of x, we're going to cover that in this section, or let's see, we're on Unit 5 and Unit 7. We're going to talk about exponential and logarithmic functions. Once again, it only crosses it once, so this has an inverse. All logarithmic functions have an inverse function. In fact, exponential functions and logarithmic functions are inverse functions. The last thing we do with inverse functions is if two functions are inverses of each other, then the composition of the functions in both orders must equal x. What I mean by that, if I take f of g of x, it has to equal x, and, that's the important part, and g of f of x has to equal x.
Call from 528.
So what I've got is, if I want to do f of g of x,
3, 6, 4, 3, 7, 7, 8, 2, 4, 7.
I would get g of x is this 1/3 x minus 2/3. I'm replacing this x with this function, so I'm going to put 3 in front and then a 2 at the end. So 3x plus 2. Then I just have to work the algebra. 3 times 1/3 is 1, so I get 1x. 3 times negative 2/3 is negative 2. And then I have a plus 2. So f of g of x is going to equal x. Then I'm going to do g of f of x. F of x is this 3x plus 2, so I'm going to put that in parentheses. That's replacing the x in 1/3 x minus 2/3. So I'm going to put a 1/3 in front, minus 2/3. Do the algebra. 1/3 times 3 is 1, so I have 1x. 1/3 multiplied by 2 is plus 2/3. And then I have a minus 2/3. So I have g of f of x. Positive 2/3 and a negative 2/3 is 0, so I'm going to get x. So yes, f of x and g of x are inverse functions. Because f of g of x equals x, and it has to be both of them, g of f of x equals x. And the last example I have, I've got this function x cubed plus 4 and the cube root of x minus 4. Well, I will tell you that x cubed and cube root of x are both inverses of each other. But these are different. This one has been moved up. This one has moved down. So let's look at this. Let's do f of g of x. So I have cube root of x minus 4 cubed plus 4. So f of g of x equals, when I cube that, what this means is I have the cube root of x minus 4 multiplied by the cube root of x minus 4, multiplied by the cube root of x minus 4. Cube root of x times the cube root of x is going to be 2 cube root of x minus 4 cube root of x minus 4 cube root of x plus 16. It's got to be multiplied by the cube root of x minus 4 again. Well, now what happens? 2 cube root of x times cube root of x. There's no way I can get an x out of this. So right away I can stop. I'm not even going to worry about it. So these are not inverses. I don't have to go on any further. There's just no way that would have equaled x. If I would have taken this, I said this one moved down 4. So if I take this first function, it's going to look like this. The inverse function has got to go through this point here. If this is the point 0, negative 4, it's got to go through the point negative 4, 0. So to go through this point here, it would look like that. And this function would be g of x equals cube root of x plus 4, like that. These are inverses, but these ones are not.